Welcome to the mind-bending world of quantum physics, where particles can be in multiple states at once and transport across space. It's like magic that can be solved by math. Superposition is when a quantum particle can be in multiple states at once. It could be spinning up and down. It could be over here and over there, all at the same time. This can happen because in the quantum world, we see these particles as waves. The electron can be everywhere at once until we measure it and collapse the wave. We are more likely to find it in certain places than others, like this probability amplitude. When we square the amplitude, it gives us the probability of finding a certain state at that point. To simplify how this probability works, let's look at a sorting hat. This sorting hat will be our electrons measuring tool. Let's pretend it has two settings, searching for red and blue electrons. If we put a red electron in while on the red setting, it's 100% red, and same with the blue on the blue setting. But what if we swap them around? It's a 0% chance of being that color. Makes sense, right? So now what would happen if we put our particle in superposition in there? Since it's in both states at once, we can't assume probability. It must come out in one defined state, because we've measured it. We can predict which state this will be using inner product formula and bracket notation. They really look like this, but for our purposes, we're going to look at them like this. Before we use them, we can draw a vector to find these complicated variables instead of using the probability amplitude. This vector represents the state of our superposition, and it must always have a magnitude of 1. We can use its red and blue vector components to write it as a sum. The value of these components depends on the angle of measurement and directly correlate to the probability amplitude. When they're a sum, we can put them in ket notation to use later. Now we can attach a bra vector. This is basically the setting our hat is on. We distribute the bra into the ket sum and replace matching and non-matching states with 1s and 0s as we learn with our hats. Using inner product formula, we know to square the answer and boom, probability the particle will be red. So we have a good guess of what the state will be, but we don't always have the right info, and in the end the electron still might come out of the hat red. Even if we're sometimes wrong, it's still pretty crazy we can predict things about the smallest building blocks of nature. That's the math magic.